to our continuing discussions on climate change and agriculture and energy.
Topic number 1. Net zero energy and carbon-free emission houses can be constructed and retrofitted to include a passive house design with elements that have great insulation and temperature control.
All right, so let's talk about the first one.
Doing net zero carbon emissions and energy for the buildings. A lot of times what they do in the colder areas is they do passive house design, which means that you have a very good insulation in your home. You have like triple pane windows like you're talking about. The walls are thicker and you don't have any leaks in your home. So when they do blow tests, you don't have any leaks. You have windows that face to the south of your house, large windows. There's different techniques. You can have solar panels in your house. You have heat pumps that you can do. So things like that can bring it down significantly towards like a net zero kind of energy house.
Well, there's also, the appliances are becoming more and more efficient. So the better, more we upgrade the appliances, it helps out as well too. Consume less power.
You have IoT too, so Internet of Things. You can control your appliances through IoT. And
IoT, yeah, that's right.
Stuff like that.
Hey, I'm glad you know about those. Yeah, that's pretty good. So that's a big emerging thing with technology. You can control them, remotely as well. Make sure, hey, I forgot to shut this off or whatever. That's a great thing too.
Topic number 2. On-site power production for industry would greatly help the electricity and heating sector using wind and solar power. This could greatly help out materials such as steel and cement.
So number 2 is on-site power for industry. Yeah. It affects the industrial sector, the commercial and residential sector, and then the electricity and heat sector. So you would be reducing the carbon emissions in all those areas if you helped out the manufacturing industry with on-site power. And so we're kind of talking about, with using solar or wind power on-site at those areas. The emphasis should be for solar power, should be more for industry and residential at first, and then later on in big solar farms in the rural areas and bringing it in. But I think that would be the best way to go about it.
I hear you. That's a big issue with solar power. You see these solar farms going up all over the place, which are great. If you want to be real efficient with that, you take some industry and some sectors in manufacturing. Like let's talk about like some of your steel and concrete. They take a lot of power to produce those things, and a lot of those manufacturing industries do have on-site power because they need so much power. They actually build their own power plant right there where they're manufacturing, like aluminum or something like that. A lot of aluminum manufacturing areas used to have their own coal power plant right there where the plant was because that was the most efficient thing to do. We replaced those things with more cleaner energy, then that would be even that much better. So I think that would be a great thing. Plus, you were talking about solar. Solar only works during certain parts of the daytime. So in the grid, you can't just go, everybody only, charge your cars in the daytime like they did, in California or whatever. But so it's unpredictable. You can't really rely on solar all the time. But an industry could plan their whole manufacturing process around when they have power. So to concentrate some of those solar power plants right next to an industry, say like a steel or aluminum manufacturing plant, then you can say, okay, my peak hour times are from this time to that time. That's what we're going to use up. That's where we're going to do the processes that take the most energy, and then we're going to by the time we're doing this, we'll have less energy, and we're shutting down at this time. So they can design it around that and be very, very efficient with solar power. I think so. I think for us, that would be a great way to use solar power.
Topic number 3. Using dedicated solar and wind power for industry could create hydrogen used for a number of applications, including steel, ammonia, and other chemicals manufacturing.
And one of the main impetuses for using solar power would be to produce hydrogen. And this would greatly affect industry in itself. When you produce hydrogen from solar, you can have, like if you have a vehicle fleet, you could use the hydrogen for that. You can make your own power, like with fuel cell technology, you have the hydrogen for that. And then in industry, as an industrial gas. We may actually get into more of that in our further videos, what hydrogen could be used for as an industrial gas, like what specific products it can make, because it can make a lot of different things. There's a multifaceted reason to produce hydrogen on site when you have the solar power.
Well, but hydrogen just want to say one thing, and that is people are always complaining, oh, hydrogen's no good because it takes so much energy to produce hydrogen, and therefore it's counterproductive because we're burning up so much fossil fuels to make hydrogen, which is a clean burning, which is a cleaner source of energy. But if you, like you said, if you had a power plant dedicated that would have, say, solar or wind or even nuclear right there to produce hydrogen, then you don't have that problem anymore. But it's concentrated and it's efficient towards producing that fuel source.
Topic number 4. Green ammonia and steel could be effectively made using solar power and hydrogen. Green materials making cement include incorporating carbon dioxide, waste, hemp, and even algae.
And that brings us to our third area, the 4 chemicals, the cement, steel, ammonia, and aluminum. 2 of those would directly need renewable hydrogen in order to make them. And that's ammonia, and then that would be steel. Steel doesn't use hydrogen right now, but what you can do is if you do use renewable hydrogen, you can make that steel at a lower temperature than what it's made now. And when you produce it from water, say for example with electrolysis using a solar panel to make the hydrogen from water, you can recycle that in a recyclable loop, because the hydrogen reacts with the iron in there and it takes up the oxygen in the iron and creates water again, and you just keep cycling that over. As far as the fertilizer industry goes, where you make ammonia, that's actually the highest produced chemical in the world is ammonia.
Wow.
And we use a lot of natural gas to do that. And when we produce it, it produces a lot of carbon dioxide, which we don't use to sequester. But if we sequestered it, then it would be considered green ammonia, and we could do it that way. But the alternative way to do it is to use solar panels. And the solar panels, of course, they can use the water from it to make hydrogen, but you also need some reactions that happen with nitrogen to combine the two, and you may be able to use solar power for that too. Cement is actually a big one. Yeah. Actually, we're looking into that. Between actually steel and cement, if you made all those as far as green processes where they weren't really producing carbon dioxide anymore, you'd reduce worldwide emissions by 15% at least.
Yeah.
Between the 2 of them.
Well, that's just in China alone. That's one of their biggest things.
Yeah.
Is they manufacture a lot of cement, and that's one of their I think totally that's like a huge percentage of their emissions because producing cement. That would help them a lot because I think they're using fossil fuels to make all that right now. But
I think they're using coal to do that. And the kind of good thing about the cement industry is there's a lot of ways to do it that they're coming up with that we're just kind of finding out. They can take carbon dioxide from a source, mix it in with the cement process, and actually that carbon dioxide gets incorporated into it, and so they reduce not only carbon dioxide from not emitting it, but also taking it in from another source. So you can do that with the steel, with the cement industry. You can use waste materials, and there's alternative ways to do it. Maybe you have hempcrete from the hemp plant, you can make kind of like a cement-like structure material, and then you also might be able to even do it with algae one of these days. We'll talk about that later. But
Topic number 5. We can make on-site power from biofuels, which includes biomass, gases, biodiesel, and other hydrocarbons provided as fuel for miniature and combined heat and power plants.
you want to talk a little bit about the next one? Is it biofuels?
Yeah, biofuels. So we were talking about on-site power. So that was like our third area. As far as on-site power goes, you can do renewables like a solar and wind, but if you're not doing that, one other options you have is to do combined heat and power on site, and you can use biomass or biogas, which is basically methane.
Right.
You could also have smaller, little mini power plants made from microturbines, reciprocating engines, and generators, and you could use biofuels for those, or hydrogen itself. You could use hydrogen, but the biofuels would be like a renewable diesel or a biodiesel or maybe alcohols. I don't know, maybe those two. Actually, that would be kind of cool if we could find a cheap way to produce biodiesel and renewable diesel, because the prices of diesel are so high right now in the U.S. But if we found a good way to do that, we not only would we reduce petroleum production of it, but we would use biofuels as a renewable source, and we'd kind of be more net zero at that point, as far as the diesel industry goes.
So, yeah, great. All right. Well, until next time, we're the Climate Change Brothers, and we're signing off.